Okay. Um, so this lecture is. Oh, I need to hide this one. Can you see the slide?
Yeah, sure. Can.
Okay. So the third session is called modeling one. We will look into the basic foundation on how do we model the document. So if we retrieve again the sequence of lesson. So last week we have covered introduction and also the user interface lah. So these two are just an introduction to give you an overview of the information retrieval. So this is the main component, modeling. This is how do we represent the document in the system, and then how do we use the representation in order to perform a lot of things like retrieval evaluation, relevant feedback, and text classification, and many more. Okay, so this is your foundation. Make sure you paham lah. So if you cannot understand or you having difficulty, you can stop me and then ask me to explain again. Okay, so we will go a few. We will go over a few model. So the most important part is this one lah, because the model start with this one, the basic concept, and then throughout the progress of the model, we will go into the vector model, and also the last one is this one. Okay, so the reason why they keep developing a new model is that the earlier model cannot capture some of the important terms that they have in the document. So they keep improving the model. So as we have discussed previously, the main component that we need to know is how do we represent the document in a system or in the data structure. Then how do we use the document representation in order to perform other things like performing the document ranking, and then how do you compute the distance between the query and the document, every document that you have. So the main objective is how do we perform the ranking function. So this is a ranking function, a function that assigns score to the document with regard to a given query. So given a query, you want to know how close or how similar is the query um, in relation to the document that you have. So every document will have some score. Okay, so it depends on how you measure them. If you say, okay, I'm measuring the distance, yeah. So the distance, the smaller is the distance, the more similar they are. But if you measuring the similarity, so if the value is higher, then the more similar they are. Okay, but if you're talking about distance, the smaller is the distance between the query and also the document, the more similar they are. Okay. So before we can perform the ranking function, we need to be able to um, design a concept of a logical framework for representing document and query. So we need to have a data structure or a platform in which we can represent the document and query, because the system doesn't know anything. They just know about 0 and 1 binary. Okay, so so our task is to understand the concept used to represent document and query, and then how do we quantify the similarity between the document and also the query. So we need to understand the ranking function that we use upon the document representation. Okay, so these are the two things that we need to know, two main tasks. How do we present them in a logical framework, and then how do we measure the similarity? How do we quantify? Okay. So in IR system, usually we use the index term or the keyword to index and retrieve document. Okay, so for example, if we're looking for certain concept, of course we are looking for the keyword or the index term. So the index term here, it, it is a keyword that has some meaning on its own and usually play the role of noun. So you're looking for a person, a thing, a place, idea, or concept. Okay, so normally we're looking at noun, not verb. So we seldom use verb like playing, announcing, reading, and so on. So in a more general form, it is any word that appear in a document. So basically, we are focusing more on the concept, the idea, or a person, or a thing, or a place. Okay. So for retrieving the document, we use the index term, and there are some method on how do we indexing the document. Okay. So when we try to indexing the document, or we give some kind of tagging or index, we need to build a framework on how do we put them together, the document and also the index term. Okay, how do we link them together? So simplicity is important because it reduces the effort of query formulation. So every time we change the query or we formulate the query, reformulate the query, of course we need to measure the distance between the document and also the query. So for example, if you key in software and then we are looking for all the document that is closely related to the term software. But if we want to change them or reformulate the query, of course we need to perform the computing the distance again, okay, in order to find more similar document. Okay, so for example, like this is you, and then you key in your query term, and then based on the term here, then they will try to match the term that they have here. Okay, so all the document that is being retrieved here will only be displayed the one that has higher ranking. Okay, so but before we can measure the distance, we have to know how do we represent this document. How do we present this document in terms of a concept in the system, in the memory of the computer. And then once we know how do we present them, then we can use the index, and then we can use the ranking function to quantify the similarity of the document with respect to the query. Okay, so a ranking is an ordering of the document that reflects how relevant they are with respect to the user query. So always we are looking at some score here. Okay, so so the whole idea of IR is we always dealing with the problem of predicting the relevancy of the document, and this problem naturally embodied a degree of uncertainty and vagueness. Means there is no assurance that the top one is the best one. There is always uncertainty, meaning that you will not get, okay, this is exactly 100 matching, or this is 90% matching. Okay, so we cannot get 100% matching. Okay, so the framework that we use contain basically four entity, or they call it quadruple. So the first one is you must have the D, which is a set of logical view for the document. Of course, you need to have the document lah kan, D. Okay, so this is the document, and then given the query. So the Q is a set of logical view for the user query. This is the information that you're looking for, and this is your resources. This is your document. Okay? And for us to measure the ranking, for us to use the ranking function, we have to have a framework. So the framework is used to um, present the representation of the document and also the query. So we must have a platform. Okay, this is platform, or what we call it a framework. And then we said, okay, this is our document here, this is our document, and this is our query, and this is our F, the framework. And then we must have a ranking function that measure the distance. So measure the distance between the D and the Q. Okay, so the ranking between these two. Okay, so normally we use DJ because the DJ here is DJ document that belong to our document, and also the query here. This is the I query that belong to a set of query. Okay, so basically we are measuring the distance between the J document and also the I query. Okay, so we just number them the J query because uh, we D is a set of logical views. So basically we have document 1 up to document N, where N is the number of document that you have. You may also have query 1 up to query M, where M refer to the M number of query you have. Okay, so this is the um, how do we describe the IR model? So based on the four component or the four entities that we have. Okay. Um, but before we proceed, there is a subjective argument here. When we say the document, the document could have certain property like the text or the images that we have or the link to other document. Okay. So when we say, okay, this is one document, but inside the document you have the images and also the text. At the same time, also this one have a link to another document. Okay, so are we considering this one as one document, or only this is considered as one document? Because normally in a web page they have a link to another document. Okay, so in this course we are looking at only the text only. Okay, so we will not look into the link and the multimedia because they have a different type of retrieving or um, computing the ranking. Okay, so we are looking at the text only. So when we talk about the text only, so we could have the semi-structure, for example, the XML. So the XML, they tell you what is the value of certain variable that you have on the page, like the person name, the address, and so on. Okay, so they call it semi-structure because in database, this is what we call structured data because you have column A, B, C, D, but in a document, this is unstructured because you have many terms inside. So this is unstructured, this is structured, this is for the database, and this is for the document unstructured. Okay, and the XML is considered as semi-structured because we have variable and values, but on each of the page they have different number of variable or entity or components. So they call it semi-structure. Okay? And for modeling the document with text, we have a few model here. So this is unstructured text because they are document. So we will look into the Boolean, the vector, and probabilistic. Okay. So the first model that we're going to look at is the Boolean, and then the second one we will look into the generalized vector, and then the last one we look into the Bayesian network. Okay. So our direction for this course is going this way. So we will not go into here, here, and here. Okay. So we're only dealing with text document. Okay? So when we try to retrieve the document, so we have two different methods. The first one is we have a query. We have individual person here, and then we have a collection of document. So ad hoc referring to anyone can query the data at any time, and there is no plan. Okay, there is no plan say that okay, based on your profile, I will give you certain information. Okay, so ad hoc is when you're trying to retrieve document and they will not return the document based on your profiling. But when we talk about profiling is each one of you will have your own domain of area that you like to research. So based on your profile, they will filter or they will pick the document that is most suitable to you based on your profile. For example, if you are in financial or if you are an accountant, so they will give you document related to financial. But if you are more on technical person, especially in AI, so they will give you more document that is more closely or similar to technical document, especially in AI lah. Okay. So filtering, they use the profile of the user. Ad hoc meaning that they will not care about your background. They will just give you whatever document that is relevant to your query. Okay. Okay. So these are some of the basic concepts that you need to know. So for each document, we will have a set of representative keyword or the index term. Okay, so each of the document we will have a keyword that represent the content of the document. So this index term is a word or group of consecutive words, meaning that you could have one term or you have n term. Okay, phrases of word. Okay, so it could be one or more than one. Okay? A pre-selected set of index terms can be used to summarize the document. So you could do the topic modeling or the topic extraction method in order to extract word that is that can be used to summarize the document. Okay. Normally we use clustering. Um, we will study clustering at the end of the course. Okay. Okay, however, it might be interesting to assume that all words are index term, full text representation. Okay, so they, they say that, okay, given this document, this is your document one. And they say that, okay, all the word yang dalam document ni is considered as your index term. Tapi if you consider them as your index term, then your index data structure will have so many spaces that you need, so many memory in order to remember that okay, this document has around 1222 index term. Okay, So it requires a lot of memory. So that's why they say the best way is we define 5 keywords that best represent the document. Okay? So in this way, we will not be wasting the memory, and also the search operation will be much faster because we are focusing on only 5 rather than the whole term that exists in the document. Okay, okay, now we look at basic concept on how do we define vocabulary. Okay, um, let T be the number of index term in the document collection, which means that we have T unique term, okay, or T unique word that exists in the document. Okay? So for that reason, the keyword that you have should be in between keyword 1 until T. Okay, so for example, if dalam document ni you have A, B, C, D. Okay, so meaning that you have keyword 1 until berapa? Keyword 2, keyword 3, and keyword 4. Okay, so we have 4 keyword here. If we have something like this, we have A, B, and then A again, and then C, and then D, and D. Okay, so for this one, the number of unique word is still the same, 4, because we have A, B, C, D. Although we have A exists twice and D exists twice. Okay, so we only refer to a unique term, index term. Okay, so that's why in the English dictionary, they list out all the possible terms that you could have in a sentence or in a document. So the number of unique terms that you have in your dictionary will be T here. Okay? So in the vocabulary, V, it consists of a set of all distinct index. So unique index term. Okay. So for example, if we have document D1 and if we have document D2 and we have document D3 and then this A have A B and then this one has B C and this is A B C. Okay? So your vocabulary for this set of document will be A B C only. Okay, so 3 unique index term for all 3. So this is the vocabulary you have for this set of document. Okay? But if you only have one document, so meaning that your vocabulary will only be A and B. Okay, boleh?
Boleh, boleh.
Okay. Okay. Now, since we have this vocabulary concept, so when we want to define the content of the document, normally we use the pattern of term occurrence. So since in computer we only have 0 and 1, so what we can do is that we list out all the vocabulary here, and then we use the 1 and 0 to indicate that that keyword exists in that document. So for example, you have vocabulary up to T. Okay, so or maybe we assume T is 3. Okay, so the pattern that we could have will be 0, 0, 0, meaning that this document is empty. And if you have document 1 and the next one will be 0, 0. Let's start from the left hand side. Hmm? You all still remember binary?
Boleh lah.
Boleh kan? So
Ya, sikit.
001, this is 1 kan? 010, this is 2.
Kosong.
and then
Oh,
kan.
oh iya.
Yes.
So this is berapa?
Tiga.
Tiga. No, bukan 001, 0012,
Empat.
empat.
So you list all the possible pattern that you have. So normally if you have this 3-bit, you have 2 to the power of 3 pattern that you have. Kan? So basically you have, okay, you start from this and then 1 and then 2 and then 3 and then 4 and then 5 and then 6 and then 7. Kan? So for the 3-bit, you have 8 pattern, 8 possible pattern. Okay. So if I have a document that has this pattern, 1, 1, 1. So what does it mean? So meaning that my, my my document consists of all those 3 keywords that you have. Kan? Assuming T is 3 lah. Tapi in this example, they generalize that, okay, if we have up to T keyword, that means we have this possible combination, which is 2 to the power of T. So we have so many patterns. So each of these pattern of term co-occurrence is called term conjunction component. Term conjunction means and. So meaning that I have this keyword 1 and keyword 2 and keyword 3 and so on sampai habis, sampai sini lah. So conjunctive referring to the first bit is on and the second bit is also on. So saying that the the last document here may have all the keyword that you have. Okay. So for each document in your document set or a query, we associate a unique term conjunctive component. We use the C here. Okay. So basically, if we are looking at this, we are looking at C, D, and then we say keyword 1 and keyword 2 and keyword 3. So term conjunctive component is referring to this. Now let me show you the next one. Okay. So this, for example, if we have this document 1, okay. So for me to represent document 1 which has only one keyword and the rest is 0, so I just say, okay, this document 1 consists of keyword 1 and not keyword 2, not because they have 0. Okay. So, because if you still remember that for the conjunctive component, you must have all the expression to be true. Okay, so since this is 0, we use the complement and this one will become 1. Kan? Tapi they're still the same because if the value for K2 is 0, so this one will become 1 lah. Okay, so this is the expression that we use to represent document 1. And for the last document here, we use this one because since they are all ones, then we just use and here lah. Okay, so that's how we represent a document in a system. Given all the vocabulary here, we use this 0 and 1. The term occurrence for each of the document that we have. Okay. Okay. Since in a system we can use an array, two-dimensional array. So we could use a concept something like this. If we have document 1 here and document 2, and then we have keyword 1, keyword 2, keyword 3. So the value here referring to whether keyword 1 exists in document 1 or keyword 1 exists in document 2. So if my F1 1 is 1, meaning that keyword 1 exists in document 1. If my F3 2 is 0, which is this one, meaning K3 does not exist in document 2. Right?
Yeah.
So this is what we call the term. This is your term, and this is your document, and they call it term document relation, or in database they call it table. Okay, in mathematics they call it matrix.
Yeah. Matrix.
Right? So
Yeah. Yeah.
term document relation or table or matrix. Okay, so from now on we will use this concept. Okay, so we use this matrix, term document matrix, in order to represent the set of document that we have, and also we capture all the unique term that we have. So the term that we have here should be unique. Okay, okay, this is the basic concept of how do we starting from the document, and then we end up with the taxonomy keyword, because like I mentioned just now, the keyword that you have here must be unique. Okay, let me erase. Buat pening sejak banyak-banyak. Okay, so this one must be unique. So since for each document that we have, we may have word something like this, play, and this one is played. Okay, this is document 1, this is document 2. Okay, so although they have um, different term that we have, but they are referring to the same idea. Okay, so we do not want to have like play here and then another one played, because they're coming from the root of the word, which is play. Okay, so we could have playing. Okay? So what we want to have is, once we get this document, we will do the tokenization, in which we take every word that exists in that document, and then we perform pre-processing, like this is what we call the stemming process. We find the root of the word. Okay? So we only capture the root of the word. Okay, this is what we call stemming here. Okay, so we have the document, and then we remove the spacing, and then we remove the stop word. Remember that when we look at the document, we don't look at the word like is atau are. They carry no meaning. The atau he atau they. Okay, so we focusing more on the idea or the nouns. So like we want to look at play, and then read, and so on, or things, or a person. Okay, so once we get all these things, all the word we will perform the stemming, except the person or individual or things. So that one will be skipped here. We don't need to do the stemming, but for the verb like playing, player, and so on, they need to go for stemming. So once we have this vocabulary, then we can list them out here, all here. Okay, so we do not want to have so many keywords here, That's why the main task is how do we minimize the number of keywords that can be used in forming the term document relation. Okay, boleh.
Boleh, boleh.
That's the time now.
And
Okay, we have 30 minutes lagi.
okay.
Boleh kan?
Boleh, boleh.
Boleh.
Dokter tanya, stemming tadi itu apa?
Dia finding the root of the word.
Oh,
Dia punya akar, the word punya initial term. So, for example, players, playing, play, semua tu, they are coming from a single term, which is play, kan?
ya, ya, ya.
So we do not want to capture the other one because the other one they carry the same meaning. Okay. For example, organization ataupun organizer ataupun organize. They come from the term
Organize.
organize, kan? So
Yeah.
stemming is finding the root of the word that we have. This stemming lah. So yang stop word ni dia remove all the word that does not carry any meaning. So if you Google what is stop word, so they list out all the is, the, we, he, and so on lah. So all the term that is not nouns or verb. Okay. Okay. Now, since we have this understanding that we could use term document metrics in order to represent them. So the first model, they use what we call it the Boolean, which refer to the value of 0 and 1, or true, false, or on and off. Because the system only know the binary values. So true and false ataupun on and off, or 0 and 1. Okay. And in the Boolean model, a simple model based on set theory will be used. And Boolean algebra saying that all the expression will be made by using true and false only, or 0 and 1. Okay? So the weight is only 0 if they do not exist. If they exist in the document, it will be 1. Okay, and since they are binary, so we can only use and, or, and not. So this is and, this is or, and this is not. Okay, so when we look at this this expression, meaning that the query must have keyword A, and okay, since this is not KC, so okay, what is the expression that make this part here is true? They use or. So you could have something like this, 1 or 0. This expression will give you 1, or 0 or 1, or 1 or 1. Kan? Because
One.
this is n, kan? Okay. So either one of these expression will give you true because they use or here. Okay. So meaning that your query is you must have keyword A and either one of these. So you could have keyword B ataupun keyword C ataupun kedua-duanya sekali. But you cannot have 0 and 0 because this expression will become 0.
Zero.
and when you add up with this, because this is n kan, so 0 also, because 1 and 0 you get 0 kan. So that's how we interpret the query like this. So we use binary or boolean because boolean is true and false. So true is 1, false is 0. Okay. Boolean algebra meaning that we use the expression of the boolean 0 and 1. Okay. Okay. Let's consider this one. Like I mentioned just now, we will use query conjunctive component. Conjunctive component referring to we are using AND operation in order to express our query. Okay, so a query Q rewritten as a disjunctive. Okay, disjunction is O. Okay, O. Um, so meaning that you have the expression in N, and then you want to change them into O expression. So from query conjunctive component to disjunct normal form. Okay, how do we translate that one? So if you look at this expression, I'm going back to here. So you could have one way, the second way, and the third way, but you cannot have this. Okay, so meaning that for this query to be true, I need to have 1 and this is 1 or 0 kan? Kan? Because this all become 1, so 1 and 1 1 ataupun 1 and this is false or 1, this one also can, ataupun you can, the last one is 1 or 1. Okay, so either you have this or this or this, so that's why we have this or. Okay, so this is in the conjunctive component. We translate into disjunction, disjunctive component. So either we could have this. This is the first one here, and then this one is this one here, and then the last one is here. Okay, so if you look at this query is in the query conjunctive component, and then we can re-return them as disjunction of those component, which is this one. Boleh? Bingung sudah?
Dokter,
Ya.
saya, saya confuse yang kenapa kita dekat sini yang di mana nih 111
Dan
lepas
O
tu
kan?
kan
O kan?
kenapa macam mana dia susun tuh 11 lepas tu yang sini saya paham yang
Yang mana ini?
yang dokter tulis itu saya paham yang satu baris
Dia,
nomor 2 daripada bawah.
they could sequence nih. So meaning that this is your A, this is your B, this is your C. This is A, B, C, A, B, C. So remember that for this one to be true, you can have 1 and
And
0 or 1 kan?
okay.
Ataupun 1 and 1 or 0 kan? Because this become 1.
Wow.
1 and 1, 1. Or you could have this 1 or 1. Tapi you just so meaning that I can go for this or this or this. Tapi if we remove the symbol semua tu, if we remove this, then they become 2 lah. Ni 1 on 1 is this.
Okay.
Oh, because we use O kan? O,
Okay.
1 is this, and then 1 This one is
yeah.
this one's supposed to be 1.
Eh,
So kalau
yeah, yeah.
this
1,
one
1, 1, 1, 1, 0, 1, 0, 1. Yeah, 1, 0, 1.
so
1, 0, 0 is false.
this one's supposed to be 1 lah.
Okay.
So no. I'm sorry. I didn't see this one.
Itu simbola.
Oh,
Not.
not. Yeah.
So betul lah tu. So
Okay.
meaning that you only can have this pen. You only can have this because since we have not, so this one will become 1. Kan?
Oh,
So
okay.
so we cannot have 101 because we have the not here. So if you take the complement of this, it will become 100. So this one will become false, and
Oh, false, false,
one
false,
and
1,
3 become 0.
0.
So I didn't see this one. Okay, not. So ini betul lah. Okay. So the main idea here is that how do you translate this query in a form of query conjunctive component into this junction of those components. So we always okay, for the query conjunctive component, this is just a straight expression saying that what would should be in the document. So di sini we just say, okay, the document must have keyword 1 and must have keyword B or not keyword C. So this one tell you what you should have in the document. Okay, but in the disjunction of those components, they give you, okay, you could have this or this or this. Okay, so to get this, you need to make all the possible value that make the query here to become true, all the combination value. So that's why you have to test for you always look for this lah, because kalau n ni both side must be 1 in order to be true, so you cannot have this one as 0. That's why we only consider 1. Yeah. Okay,
Okay.
so this was the first model lah that they have. So they have studied a lot about the um, Boolean algebra, and then they have all those things. But this is the very basic on how they represent each of the document using the keyword and then using the Boolean algebra. Okay, so this is how we represent them using the set model. So basically, they combine the set model and also the Boolean algebra. So here we are saying that, okay, um, at this area, we are saying that, okay, keyword 1 exists but not KB and KC, because the area for KC is here. Okay, so when we look at this query conjunctive component, we convert them into here. Then when we look at the set model, okay, so basically we are looking at all those documents that in the blue area there. So the when we try to describe what document will be retrieved, so all these document will be retrieved in this blue area. So we will not have them here, because when we are here, our Boolean algebra will be 0, 1, and 0, which is not in this one. Okay, so they just want to show you what area will be covered by the query. Okay. So since we are looking at the set model and also the Boolean algebra, so this is how they describe the document that will be retrieved. Okay. So if we have another example, for example, like this, um, we have this vocabulary, meaning that we have 4 keywords, and then we have the conjunctive of all these terms. So meaning that for this document J, I must have keyword A, keyword B, keyword C, and no keyword D. Okay. So if I have a query that has this one, I need to match with this one. Okay. So since in the query I do not have D, meaning that I don't care what is the value for D. So the D could be 1 or 0. So that's why the query is similar to this, but they are D. But our document is the content. Okay, I don't want to have um, keyword D, but in the query I don't have D here. So that's why the first one here and the first one here is basically coming from 111, but I don't care about D. So the D could be 0 or 1, not exist or exist. So I will expand lah. Okay, so I will expand this. So all of this is the possible document that will be retrieved, because the query here, they don't specify what is D. So no matter what is the value for D here, so it will be retrieved also. Okay. Okay. The similarity between the document and the query will be defined as one if there exists a conjunctive of query such that the conjunctive query is equal to the conjunctive of the document, meaning that if this is the same with whatever possible value you have here. So since this is the same as this one, so the similarity will be 1. So as long as you are able to match the pattern here with whatever pattern you have here for the query, based on this Boolean algebra expression, then we can say 1. Okay, and this one similarity is 0. The rest is 0 lah. Okay, only this one. But since we are using O, so um, our value will be like this 0. Oh, this is 0, 0, 5 kali. Okay, but this is O. Since we only have one, so this document match with this. Okay? So the Boolean model predicts that each document is either relevant or not relevant, meaning that yes or no. Yes, they are relevant, and no, they are not relevant. Okay? There is no degree of relevancy, meaning that this document is 90% relevant to the query. This document is 50% relevant to the query. There is no such measurement. So we cannot do the ranking here. Just either they are similar or not similar. Okay? Okay. So these are some of the drawback, disadvantages. Since the based on the similarity here is 0 and 1, so we only can say whether they are relevant and not relevant. So we cannot perform rank and also we cannot say they are partial matching or 100% matching. Information need has to be translated into Boolean expression. The Boolean query formulated by user are most often too simplistic. True and false punya matching saja lah. And the model frequently return either too few or too many document in response to a user query, because if the document match, then we say they are relevant. If no matching, zero lah written. Okay, so there'll be one time when you have so many documents that match with the query, because the final prediction is relevant and not relevant. There'll be a time when you will receive zero, because none of the pattern match with the pattern in the query. Okay, so this is not good. They cannot perform the ranking. That's why they use the term weighting. Okay, boleh follow?
Ujung-ujung tu pening.
Yang mana?
Pening sudah. Padahal yang masuk Boolean tu paling stress.
Yeah, that's why yang part ini kan dia selalu confusing. Yes.
It's okay, nanti boleh baca balik lah.
Yeah, kita mau match the because what they're trying to say here, kalau tengok dia punya ni kan, they say that yang part ni okay lah kan?
Kalau yang ini kan dokter dari mana dia dapat memang
Yang mana?
Yang ini apa ni? This bulat-bulat ni, the three conjunction tu kita yang tentukan kah di mana dia berada?
Yang di dalam graph
circle tu, ya, circle.
Okay. Okay. Kita boleh assume this is one kampung ni lah.
Okay.
So yang ini kampung untuk so wherever you are here in this circle, because you punya pattern is only this one, kan? So whatever you are inside here in KA, this one is 1, because this is the KA, this is the KB, this is KC. Okay, so that's why when we have this one, this one, semua the value is 1. This one pun 1 juga, tapi we are not in the B, so that's why this is 0. But we are in the circle of C. Okay, so when we are here, we are in the circle of A, in the circle of C, but not B. So that's why we have this. Similar to this, we are in the KA punya circle, and we are in the B punya circle, but not in the C. So that's why 0 here. Okay, so this is for the 3 variable. But kalau kita simplify this one to only 2 keyword, kita start with 1 lah. Kalau we only have keyword KA, so satu saja lah. So if in this area, that means you punya pattern is only 1 here. But if you are outside here, so this is 0. Kan? Kalau ada 2 variable KW, so you will have 2 steps. So this is KA, this is KB. So this is when you are in KA but not in KB.
Okay.
This one, when
0.
you are not in the KA but you are in the KB. So di sini when you are in KA
1, 1.
and also KB.
Oh, okay.
So this is for the 3, but if you have 4, so you have 4 something like this. Ini lepas tu
Kompleks
ini
atas
lepas tu
atas
ada lagi satu sini.
di atas
Itu.
oh ya.
Kan? Oh no, but something like that lah. So for the three variable, we can imagine the 4 is almost similar like that lah. I think you need 4D lah, 4 dimensional. Okay, so this is just to describe you using the set model, but don't worry about this one. The most important part is this one. Okay, they say that this approach works even if the vocabulary of the collection include term not in the query. For example, this term is not in the query here. Okay, so for that reason, we only try to match this one. We only try to match this one 3. So for the term that is not in the query, we must include 0 and 1 because either they exist or not exist, we still have to take. Okay, but we know that for us to have this expression, we already know that this expression can give you this disjunct normal form just by putting the value of 0 and 1. Make sure that your query can be expressed to true. Okay? So for example, if we want to this example, why we put 0 and 1 here? Because if we put this one 1, this is 1, and this is 1, so the expression will be this is 1 or 0. So this is true, kan? And then 1 and 1 will be true. So for this query, we just plug in this value, and no matter what is the value for the keyword D, this expression is still can be true. These two still can be true if you plug in into this expression. Kan? Do you agree? Yeah. So similar to this, if you plug in the value for A, B, C dalam sini, you still can get true expression. And it doesn't matter what is the value for K, D, and KD, you still can get this expression to become true. Yeah. Okay. So for the conclusion of this Boolean model, they only tell you whether the document is relevant or not relevant. So for that reason, you have no way on how to quantify the ranking of the document, because let's suppose you have 10 document or 4 document lah. Okay, so when you test using the Boolean model based on this query, so okay, we say this is relevant, this is relevant, this is not relevant, this is not relevant. But between these two, we cannot say that the first document is more important than the second document because we just say relevant, not relevant. So we cannot quantify the ranking of the document because we just use 0 and 1. Relevant or not relevant. Okay. So based on this expression, we say that the similarity is 1 if there exists the conjunctive of the query such that the conjunctive of the query is the same as the conjunctive of the document. So which means that they are the same. So for this one, this is the same with the first one. Okay. So meaning that this document is DJ is relevant. If you cannot find this pattern inside here, so that means this document J is not relevant. So that's the meaning of this one. We are comparing the pattern between the query and document J. And then if they are the same, then we put 1, relevant. If not the same, we put not relevant. Okay. Tapi masalah dia tu is we cannot perform the ranking because these two are similar. So for that reason, they introduced this one. For that one, we continue again lah, next meeting. Okay.
Okay.
So the time now is 8.40. So we stop here.
Okay. Thank you.
Give you more time to digest before we proceed lah.
Doktor,
Yes.
pasal yang query tu kan, so yang sampai D kan, example dia.
Okay.
So if ada macam more query EFGH, same lah. EFGH tu pun sama konsep dengan D tu, either 0 or 1.
So meaning that if you have KE and not included in the query,
Query.
let's say, so that means you have 4 kali lagi. So meaning that okay, you have for the KD you have 0, 1. This is for the KD. This is KE kan?
Yes.
So you don't care about these two. So the possible value is 0, 0, 0, 1,
Put same. Okay.
1, 0, and 1, 1. Okay. So these are the possible value untuk yang KD dan KE, but we don't care. Kan? So that means over here we have 1, 1, 1, 1, 1, 1. Okay. So kalau ada number of term tu yang not included in the query, so number of different expression tu dia akan naik by this, where this is number of keyword that is not in the query. Kan?
Okay, clear.
So meaning that if you have KF lagi, so you will have 0, 0, 1, no, 0, 0, 0, and then 0, 0, 1. So this one is to the power of 3. You have 8 possibility kan? So this you have many lah. So that means the first term yang sini ni yang match 1, 1, 1. So semua 1, 1, 1. Tapi you have 8 possible pattern. And still match with this. Still match with your document because the query here just looking at the 3 variable only, A, B, C. So it doesn't matter what is the value for your D, your E, and your F. So all will be matched with the query. So this is baru satu, belum lagi yang Nina. Belum lagi yang ini. Kan? So if we have 5, meaning that we have 8 kali 3
24.
possible. Ya, possible pattern. Oke. Ini baru happy hour, belum lagi yang nanti. So that's why it's better to have a short lesson. So at least you terpikir-pikir lagi kalau pergi toilet, begini.
Ya.
Kalau satu kali kasih radu kan, bisa.
Hang.
Atau mana satu mau kecap dulu.
Boleh hang kepala. Yang ini mau buat revision balik lagi nih. Oke lah, boleh.
Slowly lah kan.
Ya, boleh.
So maybe we have another meeting lagi lepas weekend lah. So weekend kita rest dulu.
Oke, boleh.
Okay?
Boleh.
So any other question that you want to ask? No.
No, dokter.